Hi everyone, so now we're going to be talking about circumference and arc length. Again, this is all about circles. They're just two different measurements of circles. So the circumference of a circle, that's just a fancy word for saying the perimeter of a circle, so the outside of a circle. If I drew a circle around myself, how long would that circle be? Like if I could put a tape measure around me in a circle, how long would it be? That is considered the circumference, like the outside of the circle. The arc length is a portion of the circumference. So, and we'll talk about these in the examples, but like if you look down at examples 3 and 4, you have almost like a bolded portion or a highlighted portion. We're looking for that portion of the circle. So we're going to take a portion of the perimeter out, or a portion of the circumference out when we talk about arc length. So let's go over these equations. The circumference equation is C is equal to 2 pi r. So C stands for circumference. Then you have 2 pi. The reason why it's 2 pi is because of that radian thing. Remember how I told you we can convert degrees to radians? All the way around a circle is 360 degrees, but it's also 2 pi radians. That's just, you don't necessarily need to know that in order to make the equation work, but that is just a cool thing. 2 pi is all the way around a circle, so it makes sense that that would be a part of the circumference. And then the R stands for the radius. If you remember from one of the first videos you watched, the radius is from the center of the circle out to the edge. So you definitely need the radius for this. Then arc length, it depends on what you've been given your measurement of the angle in. So potentially it could be measured in degrees or radians like we've talked about. If it's measured in degrees, the arc length equation is 2 pi r theta over 360. Again, the r stands for the radius, and then that theta, which kind of looks like a weird circle with another circle inside of it, that's a Greek letter, theta, and we use it to measure angles. So anything that's in degrees or radians, is what theta would be. And then if your if your angle is measured in radians, then the equation is arc length is equal to r times theta. So your radius times the angle. Now, potentially you can convert between degrees and radians like we talked about in the last video if there's one equation that you can use that's easier, but both of these equations will work as long as you use them for the right measurement. So if it's in degrees, you have to use the degree equation. If it's in radians, you have to use the radian equation. All right, so let's start going through some of these examples. The first example is asking us to find the circumference, and it gives us this circle with a radius of 10 miles. We know it's a radius because it goes from the center outward. So I'm going to just start with my circumference equation, which is C is equal to 2 pi r. And all I have to do is replace the r in this equation with what I know the radius is, which is 10. So I can write the equation C is equal to 2 pi times 10. And now I'm going to plug that into my calculator. So I'm going to say 2 times pi times 10, and it's going to give me a gross decimal. The reason why it gives me a gross decimal is because that pi is an irrational number, and so totally fine. We're just going to round our answers to the nearest hundredth. And what I will get is C is equal to 62.83. And because the radius has been measured in miles, the circumference will also be measured in miles. So my final answer is that the circumference is 62.83 miles. All right, let's go through another example. So the second example gives us not a radius, but a diameter. So all the way through a circle is 19.4. But, and there's two different formulas for circumference. We didn't talk about one. But one of them is C is equal to pi times D. So potentially on this one, I can use the diameter. The reason why this works is because we know the diameter is like 2 radiuses or 2 radii because it goes from the center out twice. So all I did was replace the 2 and the r in the original circumference formula with just D. So in this case, I can write pi times D as my equation that I'm going to use, and I'm just going to replace the D with 19.4. So I'm going to do pi times 19.4 in my calculator, and I'm going to end up with the circumference is equal to 60.95. And because the diameter was measured in meters, I'm also going to measure the circumference in meters. So we've got 60.95 meters. All right, so that's how we do circumference. It's pretty easy. Now let's talk about arc length. So in your example question, it's bolded. I just kind of highlighted mine in blue to have you see it a little bit better. So we're not finding all the way around or the perimeter of the circle now. We're only finding the highlighted or the blue chunk of it. And so because that's happening, we're going to use the arc length equations. And the arc length equation with, again, you have to decide if it's radians or degrees. For this third example, it's in degrees. So we're going to use the arc length equation for degrees, which is 2 pi r times theta over 360. And we're going to replace the r with the radius, which it tells us is 10 meters. And then we're going to replace the theta with the angle, which is 225. So I can write arc length is equal to 2 times pi times my r, which is the 10, times theta, which is 225, over 360. All right, now all I have to do is plug that into a calculator. So I'm going to do 2 times pi times 10 times 225, divide all of that by 360, and I end up with that the arc length is equal to 39.27. Again, I'm only rounding to the nearest hundredth. It will always be a never-ending decimal because of that pi. And then because my radius is measured in meters, the arc length also has to be measured in meters. Once again, so 39.27 only gives us the highlighted part of that. All right. And then the last example is another arc length equation, but now instead of being measured in degrees, it's measured in radians. So instead of using the degree arc length equation, we're going to use the radian arc length equation, which is just r times theta. So, and we know our radius is 11 miles. So I'm just going to put 11, replace the r with 11. And then our theta is in the radians. So it's 19 pi over 12. All right, and now all we have to do is plug that in. So I'm going to do 11 times 19 pi divided by 12. And I end up with the arc length is equal to 54.72. Because the radius is measured in miles, then the arc length also has to be measured in miles. So my answer is 54.72 miles. And there we have it. This is how we find the circumference or perimeter of a circle, as well as the arc length.